The where clause is similar to the search in that it limits the results set. However, rather than looking across columns for a specific value, we can use the where clause to limit based upon one or more conditions. In this example, we have the perf table and we're piping it into the where clause. For almost every single table in Log Analytics or Application Insights, there is a column which is the timestamp that particular row was inserted into the table. For most of the tables, that is named time generated. So in this example, we're going to use the time generated column, and we're going to say, go back in time 1 hour and give me everything since then. To do that, we're going to use the ago command. We'll talk more about ago in just a second, but I want to call your attention to the time filter in the toolbar. Earlier, you saw it was set to last 24 hours. Well, here it says set in query. That's because KQL was smart enough to look at this and go, oh, well, you have a time-based where clause in here, so I'm going to let it set my time range. So let's go ahead and execute this. Okay, so here's my result sets. So let's scroll over a little bit. And we're going to scroll to the right. Here is my time generated column. As you can see, it is 1 hour in the past as of the current date and time I am recording this. You should see it being 1 hour in the past for whatever date you run your query. So let's go learn a little more about ago. Let me come up here, and I've got some nice comments in here. What ago does is allows for a relative date range. Ago essentially says, well, hey, whatever the current date and time is, I want you to go back in X quantity. These can be set through these abbreviations. You can use 1D for 1 day, 1H for 1 hour. You can use M for minutes, seconds. We have milliseconds and microseconds. And these can be any number if you want. You can go back 365D to go back 1 year. You can go back 7D for 1 week. You can go back 12H for 12 hours. So you have a lot of flexibility here in determining what you want your ago value to be. Let's look at another example because we can actually take our where clause and build it up logically. Here I am using where time generated greater than or equal to ago 1 hour. And then I'm going to tack on an and clause that says, well, and I want the counter name to be equal to bytes received per second. Let's run this. And here we can see our data set is limited to counter name, and it's also the time ago of 1 hour. We can build this up with multiple and statements. Here, I'm going to have the same thing I had before, but I'm tacking on and counter value is greater than 0. This is only going to give me rows where I actually did indeed receive some bytes within the last hour. Here you can see over on the right, I've got a counter value of 1200, 479, 345, and so forth. Of course, if we can do ands, we can do ors. So I have an and statement, and within that and, I have parentheses, counter name equals, and we're going to look for bytes received a second, or we're going to look for % processor time. And there we go. You can see I've got bytes received. Let me scroll down here. And there's processor time. So I've got both of these counter names in the results. And we can actually combine these even further. Here, let's limit us even more to saying, well, I want these two counters for the last hour, but only if the counter value is greater than 0. So when we execute this results, that's what we should see. And sure enough, we can see that I've got my processor time. And if I scroll over to the right a little bit, we'll see there's our counter values, and we're only getting ones that are greater than 0. Unlike other languages, like say SQL, we can actually stack our where operators. So in this example, I pass perf to where time generated greater than or equal to ago 1 hour. I then take that result set and I pipe it into another where clause, in this case the counter name ors. And then I take that result set and pipe it into yet a third where clause. Now, why would I want to do this versus just ANDing these together? Let's say you wanted to have some sort of intermediate calculation after the very first where clause. Maybe I want to put in a new value, a new flag, and then I can then use it in the subsequent where statement. Now we'll learn how to do this a little later on in the course, but just for right now, remember that you can actually have multiple where clauses within a KQL query. Now I mentioned that where and search were very similar, and I can actually simulate a search by using a where statement. I can take my perf table, pipe it into where. I can use an asterisk that says, I want you to search across all columns, and then I want you to look for the phrase bytes. So in any column, it's going to look to see if the word bytes exists. And here we go. It took about 34 seconds to run. And if I scroll down, you'll see I have bytes total per second, bytes sent per second, bytes received, committed bytes in use. So it's found the word bytes anywhere in a column. In this case, it happened to be in the counter name column, but it actually did look through all of the columns in the perf table. Now, just like in a search, you can do positional matches. In addition to starts with, ends with, another option for both search and where is has prefix, has suffix. Starts with, ends with looks for a match only at the beginning or end of a cell, while has prefix, has suffix looks for a match on any word in the cell. And here we go. Down on our result set, you can see I've got bytes received per second. We can also run this for values at the end. I'm going to execute him, and has suffix is going to look for the word bytes at the very end. Okay, my query has now completed, and as you can see, I've got the counter name that ends in bytes, and there are other similar rows out here. I can also use the word contains if I want to, and contains will look for the word bytes anywhere in any column in the table. So if I execute this, here's our result set. And again, going to our counter name column, we have free megabytes. We've got bytes at the end. You can also see it's not case sensitive because bytes is in lowercase. We have logical disk bytes per second, so bytes is in the middle, and this pattern is going to continue through all of our data. As with search, the where clause supports regular expressions. The syntax is almost identical. We pass the perf data into the where clause. In this case, we're going to make a specific column name, instance name, the target of our where. We'll use matches regex, and we're going to use the same A through Z I used a moment ago. Basically, the bracket A-Z means any single character in the range A through Z, and the colon is just a hard-coded text. And when we run this, you're going to see my instance name column, and C colon, C colon, D colon, C colon, D colon, and so forth.